Hi there. I'm going to walk you through the test you just took. You should have your answers beside you. And if you don't, that's okay. I'm sure you remember what it is you marked. I'm just going to walk you through it and explain how I would have taken it or how a lot of eighth grade students that I've taught in the past would have taken it. Might not be the way you did it, but it might help you for the next one. Number one, what has mass and volume? Well, before I look down at my four answers, I'm going to think, what has mass and volume? Matter has mass and volume. Now I look down and I see it right here. Matter has mass and volume. So my answer number one is matter. I'm just going to scroll down. Number two, physical properties can be observed and or measured. That's a good point there, measured, without changing the substance what? So I'm not going to change anything about the substance. It's still going to be the substance. It's not going to change. It's not. None of its chemical properties are going to change. None of its physical properties are going to change. It's going to be the same substance. So let's see if we have an answer like that. Appearance, composition, chemical makeup. The best answer is chemical makeup. I can understand that some of you might have chosen composition, but a better answer is chemical makeup. And the reason why I'm saying that is that what happens when you test a substance for its chemical property, its chemical makeup changes. Okay, so chemical makeup is the best answer for number two. Let's go on now. Oops. Sorry. Which of the following properties of ethanol is a chemical property? Now, maybe you don't know anything about ethanol at all, and that's okay. So which of the following properties of gasoline, of milk, of whatever liquid you can think of, or even something that's not a liquid? It doesn't really matter what this is, what ethanol is. It doesn't matter. What matters is following properties, so the properties and chemical. So colorless, that's a physical property. Flammable, that's a chemical property. Boils at, that's a physical property. And then density. So our best answer is flammable, number three. Right here. That's the only, it's not highlighting for me, that's the only chemical property on the list. Let's move on down. Number four, a student is conducting an investigation to determine the identity. We're trying to find out what something is of an unknown substance. The following data were collected. Now, back in the day when I taught in Michigan, we gave kids at the end of the year, we would give them a jar that was this black, sludgy, had all kinds of things in it, and they had to figure out everything that was inside of it by using a whole bunch of different tests. But imagine that you have just one substance now, and we just want to figure out what it is. You're a forensic scientist, or you're working with the police department, or you're working with a building and trades organization is trying to figure out what that stuff is in the soil. Okay? The following data were collected. The substance is yellow. Okay. The substance melts at 273 degrees Celsius. Okay. Now, let me go back to number one. Yellow is a physical property. The fact that it melts at 273 degrees, that's a physical property. It's still the substance. When placed in water, the substance floats. That's testing its density. It means that if it floats, it has a density less than 1. When in the presence of a flame, the substance does not burn. Okay, well, okay, so now what you're thinking is, oh, well, that can't be a chemical property because it didn't burn. Yes, it is. The fact that it doesn't burn is a chemical property. We were lucky that it didn't burn, or maybe we were unlucky it didn't burn, but the bottom line is it didn't burn. So we know chemically it's not flammable. And number five, when the substance is added to hydrochloric acid, a gas forms and a temperature change occurs. That's for sure a chemical property. It's reacting. So 1, 2, and 3 were physical. I don't even know what the question is yet. 1, 2, and 3 are physical, and 4 and 5 are chemical. Which of these observations represent, oh, let me highlight this if I can. And I can't. Sorry. Sometimes I can. There we go. Look at that. Which of these observations represent physical properties of the substance? Well, we already said that it was 1, 2, and 3. Answer is A. You know, if you know the answer to this and you got it right, you can go ahead and skip this. This is just a video. Number 5. Which of these is a chemical property of a sheet of paper? So I'm trying to remember all my different chemical properties. You know, how does it react with other things? The paper can be crumpled. Nah, because when I uncrumple it, I get a piece of paper back. So that's nice, but still a piece of paper. The paper can be burned. Oh yeah, that's a chemical property. Because what you get when you burn a piece of paper, you burn a marshmallow, burn a stick, you get this black stuff left over. Do you know what that black stuff is? Yeah, it's carbon. The paper can be burned. Yes, that's chemical. The paper is not magnetic. Well, you still got the paper. Nothing changes about it. The magnet doesn't work. And if the magnet did work, you'd still have that piece of paper, but it's not magnetic. The paper has a smooth texture. Still paper. Let's see what the question is. Oh, which of the following is a chemical property? I'm sorry, I already read the question. Which of the following is a chemical property of a sheet of paper? And it is, the paper can be burned. Answer is B. Moving right down to 6. Silver is a white metal that is an excellent conductor of heat and electricity. Now, when silver has electricity run through it, it's still silver. When it gets hot and gets cold, it's still silver. Nothing's changing about the substance. So that's a physical property. Silver tarnishes when exposed to air and light. Tarnishing it gets that little film on it. Okay, it's reacting to the air and the light, and that's a chemical property. The density of silver is 10.49 grams per centimeter cubed. Silver is very heavy. Okay, silver is very heavy. Not as heavy as gold, but it's heavy. The melting point is 962 degrees Celsius. That's really hot. Okay, but if I cool it down to 961, I get a very hot silver bar. Nothing changes. At 1,000 degrees, it's still silver. It's just liquid silver. And the boiling point is 2,000 degrees Celsius. Hey, that's another thing. But do you realize that silver can turn into a gas? It's still silver. It's just these silver gas. I got to believe that's not real good to be around. All right. So which of these characteristics is a chemical property? Silver tarnishes. Silver is an excellent conductor. The density, the boiling point, the only one that's a chemical property. And I read all of those because you know how we've been, you've had multiple answers sometimes. The answer is A. Silver tarnishes. It combines with the light and the air and it gets that film on it. And you've got spoons in your house or silverware in your house or maybe a really nice goblet or a cup that sits out that your folks are really proud of or whatever, and it tarnishes because it's silver and you have to clean it every once in a while. All right, let's move down to number 7. Get all this in here. Number 7. First off, anytime I have a diagram, I'm going to look at the key and I'm going to try to figure out what the diagram is before I dive into the answer. Neutrons are circles. They're in there. There's 1, 2, 3, 4, 5, 6 circles. Protons are these dark things. 1, 2, 3, 4, 5, 6 dark things. So if there's 6 protons, there better be 6 electrons, and there are. Okay. Which element is represented by the model of the atom above? Which element has an atomic number of 6 because it has 6 protons? Is it A, carbon, with an atomic number of 6? Is it B, fluorine, with an atomic number of 9? C, magnesium, with an atomic number of 12? Or D, sodium, with an atomic number 11? Now, let me go back again just to check. I'm checking my work. 6 protons, So there's going to be an atomic number of 6. So the best answer is A. There you go. Hope you got that. I'm sorry it's on 2 pages. That's a drag. Might not have been on your test. I'm using a printed paper copy. Which part of the atom cannot have its location actually determined and is modeled by a cloud around the center of the atom? Well, we've talked about an electron cloud all week. So the best answer is A. And you know, you've probably heard about Schrodinger's cat and all of those things, or maybe you haven't. But the bottom line is, we really don't know where those electrons are at any point in time. If we could somehow freeze an electron, we know there'd be 2 that are really close to the nucleus of the atom, and we know the rest would be spread out in these orbits around it. But they don't sit there. They're moving all the time. But we call that an electron cloud. Okay, so the answer to 8A is electron. An atom of gold with 79 protons, so I'm thinking for myself, 79 protons, that's its atomic number, 79, and 118 neutrons would have how many electrons? Well, you see, this 118 neutrons, they're just throwing you off. They're just trying to see if you really understand that the number of protons equal the number of electrons. So an atom of gold with 79 protons would have 79 electrons. Best answer, B. I hope you've gotten these right all so far. All right. Or if you did it again, and you're going to, if you need to, you'll do it again. I hope you get them right next time. Number 10. Where are electrons located in an atom? Okay, so we know they're in an electron cloud. So I'm glancing down here, and I don't see an electron cloud. With the quarks, that's just a trick. There are such things as quarks, but that's not the answer. With the neutrons, which means are electrons in the nucleus of the atom? Nope. Outside the nucleus? Yes, they are. But now that might not be the best answer. But that's where they are. Near the protons? No. Best answer is C, outside the nucleus. Are you keeping track of this? Are you writing a few of these down? I'm doing my best. I'm checking to see how long we've been going. Wow, 12 minutes. Okay, I'm not going to go any faster, but we have been going for a long time. Number 11. The table shows some characteristics of a few atoms. So I've got carbon with an atomic number of 6. I've got number of something. There's a question mark there, 6. And the mass is 12. Well, if it's got an atomic number of 6 and has 6, and has atomic mass of 12, there's a couple different things this could be, right? So if 6 and 6 is 12, that could mean that that's the number of neutrons. That could also be the number of. It wouldn't say number of for atomic number. 24 and 28 equal 52. This must be the number of neutrons. 12 plus 12 is 24. 11 plus 12 is 23. We did that on that periodic chart question. Okay, so let's see what the question is. The mass of an element is the sum of the atomic number and the number of, what we just said, number of neutrons. The best answer for 12 is neutrons. We know that. And this chart just kind of helps us with that a little bit. The mass of an element is the sum of the atomic number and the number of neutrons. Number 12. What particle always has a mass of 1 atomic mass unit and no charge? Okay, so it's pretty heavy because it's got a mass of 1 unit, okay? But, there's always a but, there's no charge. So it can't be a proton. It's too big for an electron. Let's go look. Oh, I bet it's a neutron. No charge. That's my key. No charge. It's got to be a neutron. Protons have a charge. Electrons have a charge. Neutrons, no charge. Number 13. What are the parts that make up an atom? So before I even look down there, I know I'm going to have protons, neutrons, and electrons. Now, sometimes some scientists will talk about the nucleus, okay, but that's just kind of like the area where the neutrons and protons hang out. Maybe one of our answers here is going to have nucleus in it. I don't know. Let's check. Electrons, neutrons, and protons. That's a pretty good answer. Electrons, protons, and gamma rays. Not so much. Neutrons, photons, and beta particles. Now, these are all real things, but they don't necessarily make up an atom. Neutrons, protons, and alpha particles. Again, these are real things, but that's not the right answer. The best answer is electrons, neutrons, and protons. Sometimes the best answer is the easiest answer, and 13 is A. Makes up the atom. You could have in parentheses here the nucleus, but it's really not a thing. It's more of an area. Number 14. An atom's mass number is 210. Whoa, that's a pretty big atom. And its atomic number is 85. How many neutrons does the atom have? Okay, you're gonna have to do some math here, guys. I mean, I can probably help you. Okay, without doing the math, let's pretend that we are anti-math, and I hope you're not. But if it has an atomic number of 210, if it has a mass of 210 and 85 of those are protons, well, 85 could not be the number of neutrons, because I know that 85 and 85 does not equal 210. Excuse me. Could it be 125? Yeah, 210 minus 85 could be, without doing the math, could be 125. It can't be 210. That's the atomic mass. It can't be bigger, can't be 295. So without doing any math, and I hope you did the math, the best answer is 125. Or you could just break down and do the math. And 210 minus 85 is, can't subtract 5 from 0, so you borrow. And 10 minus 5 is 5. And 20 minus 8 is 12. So you get 125. Best answer is B. Hope you did the math. 13. Woo! I'm going to see if I can reduce my screen here a little bit. There we go. All right. 13. Come back. Oh, 15. So before I look at the question, okay, I'm going to familiarize myself with the diagram. So I can see for sure that there's 1, 2 electrons in the inner orbits, and 1, 2, 3, 4, 5 in the outer orbits. 1, 2, 3. Yep. So I'm guessing that it has an atomic number before I look of 7, because it has 7 electrons if this is a neutral atom. And I also can tell that 1, 2, 3, 4, 5 of these are outside or in the last ring. Okay, and I know that those are called the valence electrons. I really can't count in here. I hope they don't want me to count in there. But I know there is 2 electrons in the inner circle and 5 in the outer. So let's look at the question. How many valence electrons does this have? All right, this has 5 valence electrons. Right there. Sorry, I'm squinting. Couldn't see it. 5 valence electrons. The answer is C. All right, let's move on. All right, I'm going to see if I can make my screen a little bigger again. Sorry about that. Maybe one more time. Okay. All right. So this is a tile from the periodic chart. And again, it's a diagram. So before I look at my my question, I'm going to look at the diagram first. And I know we usually read the question first, and but I think when there's diagrams, you get everything out of the diagram you can, and then you look at the question. That's just mine. Maybe you've got a better strategy. So this tile has an atomic number of 1. So that tells me it's got 1 proton. Its symbol is H, and I know from experience that that means it's hydrogen. And down here is its real mass, and its real mass is 1.0079. And I know that's not very close to 2, so its atomic mass number is going to be 1. So now let's read the question. Oh, and if its atomic mass number is 1 and it's got 1 proton, how many neutrons does it have? 0. All right. An atom of hydrogen consists of one proton surrounded by 1 electron, because remember, it's going to have the same number of electrons as it has protons. So let's check to see what our answer is. An atom of hydrogen consists of 1 proton, so it could be this one or it could be this one, all right? Surrounded by one electron. So the best answer is C. Proton, I'm trying to make that, there we go. One proton surrounded by one electron. All right, so the answer is 16 is C. Hang on, we're almost done. At the center of every atom is a small, dense blank that is positively charged. Well, no matter what, no matter how many neutrons there are, this dense nucleus is positively charged. At the center of every atom lies a small, dense nucleus. It's speaking about the whole thing. Now, I could see that you might say a small, dense proton that is positively charged, but proton, and it's not the right answer. And proton is not one of these answers, so you couldn't choose it anyway. The best answer is nucleus. The nucleus is at the center of the atom and holds all the protons and neutrons. Okay, and it's very small. It's incredibly small, considering how big our world is. Electrons take up most of the space. Let's move on to 18. Now I'm hurrying a little bit. All right, number 18. I'm going to have to make it a little smaller. Here we go. So again, I'm going to look all over this diagram before I look at the question. So in the middle, it says it's got 13 protons and 14 neutrons. So if it has 13 protons, it's going to have, without even counting, but I'm going to, without any counting, it should have 13 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it has 13 protons and 13 electrons. And I'm going to check it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if it has 13 and 13, it's got to be neutral. I don't know if that's the question or not, but I'm looking for every clue I've got. Oh, and if it has 13 protons and 14 neutrons, I know that it has an atomic mass of 27. All right, so I do all of that work, and what is the atomic number of the atom shown? 13, because it has 13 protons, and the best answer is B. Wow. But I was ready for whatever it threw at me. Number 19. Let me see if I can make this a little bit bigger for you. All right, so here we go. Again, I'm going to look all over this diagram, all over this picture. The element is potassium, K. I know that just because I know things, okay? And have you ever been down the cereal aisle and looked at the cereal Special K? Well, that's because it has a lot of potassium in it. Fact you learned here in science class. It has an atomic number of 19. That means that it has 19 protons. It has 19 electrons. And it's got an atomic mass of 39.0983, which is much closer to 39 than it is to 40. So we're going to say that it has an atomic mass number of 39. So what is 20? Well, 20 is not, so the question is, 20 is the blank of potassium. Well, it's not the number of electrons. It's not the atomic mass. Oh, it's not the atomic mass number, but 39 minus 19, math in my head, is 20. 20 is the number of neutrons in an atom of potassium. Sweet. Now that took a little bit of work. Okay? And finally, number 20. What does this symbol tell us? Well, it has an atomic number of 5. It has 5 protons. It has 5 electrons. It has an atomic mass of 10.81, and 10.81 is a lot closer to 11 than it is to 10, so it has an atomic mass number of 11. 5, boron, 11. 11 minus 5 is 6. It's got six neutrons. It has 5 electrons. It has 5 protons. Atomic mass number of 11. How many electrons are in an electrically neutral atom of boron? How many electrons? Electrically neutral if it has 5 protons It has 5 electrons. The best answer is B, 5. Matches up. 5 protons, 5 electrons. All right. If you watch this because you're getting ready to take a retake, I hope you do super well. Reach out to me. Reach out to your science teacher if you have any questions.